Hello everybody and welcome to episode 24 of the video series in which we program an entire video game from scratch in the C programming language. Now the last time in episode 23 we left off, we had finished initializing the sound engine, which is right here, Initialize sound engine. So we've initialized the sound engine, but we haven't actually loaded a sound to play yet. So let's go ahead and do that. To start that, I'm going to start by creating a new data structure. And this data structure is going to be called game sound. And it's going to look a lot like game bitmap, which is in my opinion, I think it's pretty cool. I like it when things work out this way, so that all your data structures, they bear a similarity to one another. Anyway, so what I mean by that is this data structure is going to have two members. The first member is going to be a wave format EX, and the analogy, I'm trying to draw an analogy here. It's similar to the bitmap info for the game bitmap data structure, in that this wave format EX is going to hold the metadata about the information about our wave file, about our sound. And then finally, we do need memory, but instead of just a raw like void star pointer, we're actually going to use I think it's like X audio to PA X audio to buffer. That's all it is. X audio to buffer. There. And we're going to call that, I guess we're going to call that buffer. So this is where our where we will allocate memory to hold the actual sound data. So, and that's it. That's all we need. So now I'm going to go back over to the C file. No, I'm not. I'm going to stay here in the header file because I'm going to create a new function. I'm going to define a new function. I'm going to call it load. Actually, what do we call? Okay, we're going to call it load wave from file. And as before, we're going to take in a file name and a pointer to a game sound. Okay, looks good. So I'm going to copy that and go over to my C file. Oh wait, it doesn't look good. It doesn't return anything. I don't know what it should return. I'm just gonna do I'll do a D word. We may adjust that later. Okay. Keyword result. And as usual, it's going to have the same structure, same skeletal outline that all these functions have. I kind of like to make all my functions the same way. And then I'm going to do, I'm not sure where I should load the sound, so I'm probably just going to stick it in WinMain for now. I'll do it right after the initialization of the sound engine, which is right here. So in WinMain, I'm going to do if load wave from file, and the file name will be B assets menu navigate .wav. Okay. assets menu navigate.wav. And then the pointer to the game sound, which we obviously need to make. I'm going to make it a global variable for the time being. I'm going to call it, we need a game sound. I'm going to call it G menu navigate. Okay. Back down to WinMain. Address of G menu navigate. And if that does not equal error success, then we will have to exit the game as usual. Okay. All right, let's work on this function for a little bit. All right, so we're going to need some local variables. I'm going to have a D word named riff, and this stands for, if you look up the WAV file format and click on one of these, you'll see that the WAV file format is a subset of Microsoft's riff specification. And so the first 4 bytes of the file should contain the letters riff, R-I-F-F, in ASCII form. So that's big Indian, and if it's little Indian, it'll be reversed. So I could, it's a D word is 4 bytes. It doesn't really matter if it's the data type is a D word or if it's like an array of 4 characters. It's still, 4 bytes is 4 bytes, right? And let's see, we're going to make a local, are we though? I may or may not make a local game sound. I was thinking of like building the game sound locally inside this function and then just copying it to the global one, but I don't think that's necessary. So what else do we need? Unit 16T data offset, because this is going to be just like when we parsed the file format of 32-bit per pixel bitmaps, in that we're going to open the file from the disk and we're going to read a few bytes at a time until we find the quote-unquote data chunks that we are looking for. And the WAV file format is a little bit more complicated than the 32-bit bits per pixel bitmap that we did earlier. So I'm going to end up doing something we call a data chunk searcher. And the reason I'm going to do that is because we're going to basically iterate through the first, 512 bytes or so of the file, looking for a very particular data chunk. And if we don't find it within the first 512 bytes of the file, then we will exit the function, because this is obviously, we've got the wrong file. We're not looking at a WAV file apparently. All right, so let's see. Bool data chunk found and data chunk size. Alright, I'm going to borrow from up here the load 32 BPP bitmap from file. I'm going to borrow this chunk right here. And go back to load wave. Okay, Now we need obviously a handle, invalid handle value, error. Should I make this? I'll rename this error just to be consistent. Okay, we have opened the file. Oh. If file handle is not null and file handle does not equal invalid handle value, then close handle. Okay, we're going to read the first first 4 bytes of the file, and we're going to store that in riff. 4 bytes. Or to be fancier, you could do size of D word to make it more size of D word, which is 4, same thing. Keyword number of bytes read. And then we're going to make sure that it's FF, which is 0x 46, 46, 49, 52. Those are the bytes for RIFF. Right. If I open this file in HXD, it will be it'll be just like what we did with the bitmap file. If you look at the first 4 bytes, it's going the opposite way because of Little Endian byte order. It's going to be 46, 46, 49, 52. And those are simply, that's simply the code for RIFF. I think that is pretty much clear at this point. I'm going to run it and see what happens. Just to make sure we haven't gotten any errors up to this point. And we're fine. Okay, so the wave format EX, there is actually, just like in the bitmap, there's a wave format EX data structure embedded directly in this file. So we don't have to do too much work to get it. And it's 20 bytes offset. So if I go back and look at the file format again, it starts audio format. I think it starts right there. Okay, so at 20, we have 2 bytes, which is the audio format. PCM equals 1. Values other than 1 indicate some form of compression. So when I look at my game sound and I look at the wave format, right, let's just type this out. See what happens. So let's do a mem copy. No, wait, let's not do a mem copy. Let's do a set file pointer, file handle, distance to move 20 from the beginning. And let me go here and make sure. Borrow this again. Load wave from file. Darn it. I accidentally hit like Control X and Control C and Control V at the same time. So I lost what was on my clipboard. So I'm going to go copy it again. Set file pointer. Load wave. And this should be sound wave format. Size of wave format EX. That's how much we're going to read. Number of bytes read. Okay, so I think that's correct. Let me set a breakpoint and run there just to see what happens. Okay. Now I'm going to place game sound on our watch list. You can see that it is currently initialized to all zeros. Now let me take one step. And what happened? Wave format tag is 1, channels is 1, samples per second is that number, bytes per second, average bytes per second is that number, block of line is 2, bits per sample 16, and then the CV size 6164. Let me turn it off hexadecimal here. Bits per sample 16. So this this data looks sane. Sorry, I'm just looking at this file format, making sure that that's right. 20 bytes from the beginning of the file. There should be a wave format EX. Yeah, obviously 44,100 is a valid that is the true sample rate. So I don't really have any doubts that I've gotten that correct. So all right, let's go ahead and stop it. Okay, let's see what else. So we'll say let's do some sanity checks on the data now that we've loaded some of it. We'll do if game sound wave format dot in block a line is not equal to game sound wave format dot channels times bits per sample, game sound dot bits per sample divided by 8. Or if the format tag is not equal to 1, which is PCM format, or the format dot bits per sample is not 16. Now, if any of those things don't match, then we'll say that you are not reading the right kind of file. I got a parentheses, parenthesis. Match. Go to exit. I may change this later on if we decide to support other types of wave files for our sound effects. I'm not worried about music because we are not going to use this function to load background music. We're going to do a totally different thing for music, which is I'm going to do either MP3 or OGG Vorbis for the background music, and the reason why is because you know, as you're probably aware, wave files, they're uncompressed, and so they're typically huge, and you know, I don't want the background music to be, you know, 800 megabytes or something. So but on the other hand, the sound effects are typically like half a second long or less, so it's not that important. I'll just load them as uncompressed waves. That being said, you know, if I want to start supporting other types of wave files that like have different bits per sample and all that kind of stuff, different wave formats, then I might change this function later. Might not. Let me, I need to log all these things. Level error. Message. Okay. Create file A. Failed with 0x%.8 LX. Now, the reason you saw me do this, where I went and I was about to put the log function right there, and then a second later I thought better of it and I put it right there instead after the call to get last error. And the simple reason why is because it's typically best practice to, if you are going to call get last error in order to check the reason why a particular API function failed, you need to call get last error immediately after calling that API function. And the reason why is because a lot of functions can set last error. They either might reset they might actually reset last error to 0, or set it to something else, even if those functions don't fail. So that's all that is. It's just best practice to call get last error immediately as soon as you have detected that an API function a Windows API function like this has failed. Anyway, so that's all there is to that. And I'm going to log all of these errors. We're going to say read file failed. And this is going to say, in this case it doesn't matter because we aren't calling get last error, so you can essentially don't have to worry about it. But I'm going to say first 4 bytes of this file are not riff. And on this one, I'm going to do set file pointer. Nothing interesting here. On this one, nothing interesting going on yet. Okay. This wave file did not meet the format requirements. Only PCM format 44.1 kilohertz, 16 bits per sample wave files are supported. Okay. And like I said, that's an arbitrary requirement. I'm simply enforcing that requirement just because the program that I used to generate the sound effects, which I generated last time, which is called BFXR or BFXer, that's the format of wave file that it generates, and so that's the file format that I'll use. Like I said, we may change it later. If we get smarter, we may come back to this. Okay, now here is the weird part. So we're looking for the data chunk, and the thing is, the thing that makes the wave file format more complicated than, say, for example, the bitmap file format is because the wave file format, it has a data chunk in it that can be an arbitrary at an arbitrary offset inside the wave file. Basically, it could be at like 30 bytes into the file. It might be 40 bytes into the file or 48 bytes into the file. We can't be sure, and the reason why that is because you can fit. I think what I'm saying is accurate, but my understanding is the reason why the file format is like that is because there's space at the beginning of the WAV file for the user to put their own metadata in the WAV file. Like you can put, artist name and album name and all this kind of stuff at the beginning of the WAV file. And when you put that sort of metadata into the WAV file, it pushes the data chunk further out into the WAV file. So we have to search for the data chunk manually. So I'm going to do a while loop. While data chunk found equals false, we are going to do something like, we need to set file pointer in our file to data chunk offset, is it? Data chunk offset, and we're going to increment data chunk offset every iteration of this loop. So it's going to start at the beginning of this file, and then we are going to read a file. Read a file. Okay, read file. And we're going to store this in data chunk searcher. We're going to store, which is a D word, right? So we're going to store 4 bytes, read file, buffer, number of bytes to read, which is 4, number of bytes read will be 4, if data chunk searcher equals 0x61 6174 6164. Let's look at the file and see if we can find. Alright, starting with a 64, there it is right there. 64 61 74 61. It actually spells the letters data. Data backwards. Okay, if the data chunk searcher is that, then we have found data chunk found equals true, and let's break. Else we are going to increment data chunk offset. So the assumption here is that the data chunk is always going to be at an offset that is a multiple of 4, and I'm pretty sure that that's always true. And we also need to do something here to make sure that this doesn't turn into an infinite loop. If someone were to feed it a malformed WAV file, or if someone were to feed it some other sort of file that was not a WAV file, obviously the data chunk would never be found, and we could end up scanning, megabytes and megabytes worth of file for a data chunk that we are never going to find. So we have to make sure that that doesn't happen. So if data chunk offset is greater than 256. Again, I picked that number arbitrarily. I don't know if it's technically possible for the data chunk to be at an offset of greater than 256. Chunk ID, format, sound data, the actual sound data. I would feel really dumb if the data chunk was always at 44 bytes off. That would make me feel pretty silly after I did all this stuff thinking that it was at an arbitrary offset somewhere towards the beginning of the file. I'm not sure why I thought that. I think you can have an arbitrary number of subchunks before here, and that pushes the offset of the data chunk further out. Or I might be thinking of, no, not extra params. I really don't know where I got that idea. I'll have to refresh myself on the file format. Somehow I got the idea that this needed to be done, and if it doesn't, then I would feel really silly. But hey, you know what? The code is going to work anyway. So anyway, let's just pretend like we're doing the right thing here for now. Data type mismatch, and this is like if we've searched too far and we still haven't found the data chunk, then we know that this is never going to work. Data chunk not found within first 256 bytes of this file. Okay, and then we go to the exit. We have to exit. Okay, and that does it for our while loop. Now let's go ahead and we need to set this file pointer to data chunk offset +4. I think that's correct. And then we're going to read, this should be the size of the audio data. So we're going to save this in, did we even make a variable called data chunk size? We did, data chunk size. So this should be the size of the data chunk. Data chunk size. Okay, so let's set a breakpoint right there and see what happens. Make sure that we don't have any errors up to this point. Okay. Data chunk found equals true. Data chunk offset as 36. Data chunk offset was at 36. Yep, which is right here. Starts right here. That's the word, that's the letters data, and then 4 bytes past that should be this is the number of bytes in the data, which is also samples times channels times bits per sample divided by 8. (27A0). So that, I believe, is the size of the data chunk. And I believe it can be up to 4 bytes. Yeah, it can be up to 4 bytes. So you can technically have a 4 gigabyte WAV file if you really wanted to. Data chunk size is 10,144 bytes. Look at there, 10,144 bytes. Okay, everything looked good. Everything looks good. So we now know the size of the data, and we know the format of the data. All that is left to do is to go get it. We need to allocate some memory to hold this. So we need to allocate like 10,144 bytes or whatever to hold this sound. So game sound buffer dot p audio data, pointer to the audio data, heap equals heap alloc get process heap. Flags will be heap 0, and the size is going to be the data chunk size. And if that didn't work, then error equals error not enough memory. Go to exit. Let's log that error. We'll do heap alloc failed with not enough memory. Okay, we allocated that memory. Now we simply need to set file pointer offset +8. I guess that's right. It is. Okay. And we need one final call to read file, and then we'll be done. If read file, that file, and we are going to store it right here in game sound buffer.p audio data, and the size is going to be data chunk size. Yeah, data chunk size is how much we're going to read. Okay, that should be it. Let's run it. Aha! We crashed. Why did we crash? What's the call stack? What? What? We crashed in load 32-bit bitmap where we have never crashed here before. Line 776. Line 776. What in the world have we done? Okay. Let's go find line 776. Six. File was down 0 downstanding. Something is horribly horribly wrong here. Yeah, we're logging an info. So it was definitely here, loading successful, and it crashed right here. And it crashed because of arg pointer. So I feel like this is probably due to what we were just working on. I have a feeling we must have trampled something. We must have written over some buffer. Let me go back to wave file. Load function different const qualifiers. Okay. Pointer. Actually, maybe this should be like that. I think that actually might be the problem. Is I should have passed. I basically should not have passed the address of this thing. I should have passed this thing itself. So let's see if it works now. Yes, it works without crashing, and so yeah, I'm pretty sure the reason we crashed was that I had this, and it basically ended up reading, or I should say writing some data to some other variable in memory and overwrote something. Let me go look at WinMain real quick. See where this happened. So we were load wave files here. Load wave file is here. Where is initialize hero? And initialize hero is here. Yeah, see, that's my theory, and I'm sticking to it. Is I say we wrote into the wrong memory location in this function, and then by the time we get to this function, initialize hero, which is where we do the loading of all those bitmaps for the animation for the hero where he walks around. That is my story, and I'm sticking to it. So should be fixed now. And on top of that, we are finished with this function, load wave from file. Oh, and you know what? Last thing I'm going to do is I'm going to log if error equals success, else do that. Okay. Failed to load %s error is going to be that. Okay, failed to load file name, and there is the error. If we succeeded, we are also going to log the same message, but we're going to log it at an informational level, and we're going to say successfully loaded %s and no error. Okay. Works fine. Get content. Where's the gameb.log file? There it is right there in our log file. We load wave from file, successfully loaded ./assets/menu navigate.wave. Successfully loaded. Okay, that's it for that function. How much time do we have? Oof, 50 minutes. I don't know if we have enough time, but we're gonna try. Gotta make some new functions. Gotta make some new functions. We're going to call this. We're gonna call it play sound, and we're going to take in. Oh, no, it can't be called play sound because play sound is already taken. It's already taken by some silly inferior Windows API version. So I'm going to call mine play game sound, and it's going to take in a sound. I guess that's all I need. And for the record, I'll do something about this const qualifier warning. Let's see if I need anything else. No, should be fine. Okay, main.c. And we're just going to, it's not going to return anything, this function won't return anything because I guess we'll just assume that it will never fail. I'm not going to tolerate an error in this function where it just doesn't play a sound that we told it to play. Alright, so let's see. Play sound. I think this should be a pretty simple function. Basically, we take our global sound effects source voice that we created, audio sound effect source voice, and remember we created it as an array, so there are actually 4 of them. So we need to use the selector G sound effects source voice selector will be our index. Virtual table. And by the way, I think I talked about this last episode, but if we were writing C++, this virtual table bit right here would be implied, so you wouldn't have to type it. But since we're writing in C, we do have to type it out and submit source buffer. And same issue here, where if we were writing in C++, this variable would it be implied, but since we're writing in C, it is not implied. We have to spell it out. And we supplied a buffer, which is going to be our game, our G menu navigate dot buffer, and then finally buffer WMA. I forget what that is, but we don't need it. And then we need to do the same. GX audio SFX source voice, GSFX source voice selector, virtual table, submit. No, start. And then again with the GX audio SFX source voice. Commit now. Okay. Now what we're going to do is we're going to increment the sound effects source voice selector, and remember the reason I'm doing that is so that we could potentially have 4 sound effects source voices that we could play on simultaneously. So hypothetically, I don't I don't really anticipate playing 4 sound effects at the same time. That would probably be cacophonous, but in theory, if we had to have 4 sound effects that overlapped one another, we could do so without them interrupting each other. If G sound effect source of voice selector is greater than the number of sound effect source voices minus 1, then put it back to 0. And that is it, ladies and gentlemen. We are ready to play this sound. So where do we want to play it? So I feel like we should probably play it. So this is the process player input underscore title screen function. And since the sound is going to play in response to us pressing the key, I think it probably is the best idea to play it here. And I'm going to do, so it should only play when the selected item moves, right? So right here I'm going to do play game sound, and we're going to pass it the pointer to our G menu navigate sound. And same thing for when the menu item moves up. Okay, the moment of truth. Moment of truth. And I apologize in advance if this is really loud. I have no idea how loud it's going to come through in the video. Oh, it's not working. Wait. Speakers. Yeah, my speakers are on. Screen. Sound. Oh. Well, first of all, I messed that up. That should be game sound buffer. Okay, am I missing anything else? I am not. That should be working. Okay, my speakers are on. So, what have I done wrong? What have I done wrong? Should be making sounds. Why isn't it making sounds? Why are you not making sounds? Is what I want to know. Did we do something incorrectly in loading the sound? Oh, wait. File handle. Okay. No, I think that's right. We already set the file pointer to offset +8. Set a breakpoint. There's our game sound. The wave format is correct. The buffer, it has, everything looks correct. Number of bytes read, 10,144. Copy value, test. Let's go to debug, Windows, memory 1. Yeah, 00 D017. D017 C413. So yes, the data did in fact get read from this file. It is now in memory in the right place. Okay. Oh, so, okay, I forgot to have to fill out a couple of these fields manually, and I forgot to do that. So, game sound, buffer, flags equals X audio 2 end of stream, and game sound buffer dot audio bytes equals data chunk size. I basically have to put the size so it knows how big the audio file is, and I think that's it. I think that was our only mistake. Play. Let's go. Let's go. Bingo. We got sound. All right, there it is. So, as always, thank you for watching, and please like and subscribe. If you have any comments or questions, please feel free to leave those comments or questions on the video, and I will talk about those on an upcoming episode. I'll talk about your questions and comments. Also, don't forget that there is a GitHub repository to go along with this project, so that you can follow along at home if you so desire. And that is it. So until next time, I'll see you in a few days. Bye.